This video is to go along with problem 1 that I have created. And in this problem, after the first step of just, having your image and taking in your problem and rereading it, the first step is really to identify what it means to be parallel to that line segment BA or AB, however you want to call it. So what I did was in GeoGebra, I selected a random point and then went parallel to that segment, and this is actually that segment. Okay, and then additionally what I did was I also intersected that segment, or I'm sorry, that line with segment BC. So now I have an intersecting point. So what this is going to show is that point R is numerous possibilities. It does not have to have one set location, but to describe the location in the best terminology, we first want to be able to eliminate that it's not going to be outside of triangle ABC, and that is in the given information, but a lot of times our students read problems so carefully that they do not understand what is actually happening in the problem. So that choice A would be eliminated right away, just based on the reading. And then we're looking at choices B and D, and in those choices it says the word can only. If it could only exist on the line segment BC, which is choice D, then this point that's on here would not be able to exist on that line. So D is going to be false and will not be used as the final answer because the point could be on BC, but it can also be in the interior of the triangle. Notice how I am moving this point that is inside the triangle. And if my given direction said it needed to be contained on or within, the on quality would be, for instance, it could be located on the segment AC, but it could also be located on the segment BC. So there are numerous possibilities here. The reason that I cannot really say that it would be on BA is that parallel lines are typically not coincidental lines. So we're not going to use the coincidental idea and just use the normal traditional parallel sense of two unique parallel lines. So this is uniquely parallel to segment BA. And using this demonstration, it really clearly shows that it could be contained inside the shape, but it could also be contained on the hypotenuse of that shape. And again, the hypotenuse point that could be contained is really the one right here, point E, that is showing that intersection. And as I drag that parallel line back and forth, it is staying parallel, but it's still currently on that triangle. Okay?